Hi guys, this is Mrs. Miller. I'm going through the review for Chapter 1. I'm going to answer all these questions, show you how to do them all, and then give you some bonus topics at the end of the recording that you need to make sure that you also look at before taking the test, because you'll see problems on those as well, but they aren't represented on this review. So let's get started. Okay, so let's get started on the first one. The first problem, what you need to do is you need to distribute first and foremost. The 2 goes to everything in the parentheses. I don't take it to the -5, so that just comes down. And then I take the -3 to everything in this parenthesis. Remember, when you take -3 times -1, that becomes a +3, and bring that final 3x down. After you've distributed correctly, then you need to combine like terms on each side of the equal sign. So you're going to be left with 2x minus 1 equals -6x, because remember, these two things get basically added together since they're the same sign, same variable, and then plus 3. And now at this point, hopefully you guys know how to solve a basic equation. I tend to move my 6x this way because it's negative and I want to try to keep my x positive. So that'll give me 8x. And then I'm going to take that -1 and add it to the other side. So that equals 4. And then my final step tells me to divide. And I divide on both sides. So x equals 1/2. So that should go fairly well. Okay, the second one is an absolute value equation. Remember, absolute value equations, you're basically making 2 equations. You have to make sure that there's nothing that's in front of it, there's no multiplier up there, and there's nothing in the back of it, nothing being added or subtracted. If there's anything in front or in behind it, then you need to add that to the other side and divide it to the other side as well. You can't split this to 2 equations until you get the absolute value on its own. Okay, so now we're going to break this into the 2 equations since there's nothing in front or behind this. One of them is exactly what it says. And then the other equation is the same inside the absolute values, but I have to make the opposite number, or the number the opposite sign. So instead of +12 becomes -12. And now I'm just solving this equation. So the first step is get rid of that 3 in the denominators. We do that by multiplying it to both sides. And so that gives me x plus 6 equals 36. And over here, x plus 6 equals -36. And so my final steps tell me to subtract. So that's x is 30. And over here, subtract, that's x is -42. And we should be good with those 2. Okay, so let's look at the third one. The third one's got a little bit harder. The first thing you need to do is distribute the 4 to everything up top. So that's 4x plus 12. 1 plus 3x equals 5/2. And then hopefully you recognize that this is just a proportion. There isn't really anything going on here. Remember when we solve proportions, it's that butterfly method where you multiply the diagonals of the proportion together. So when I do that, on the green, I'm going to have 2 parentheses 4x plus 12. And then on the red, I'm going to have 5 parentheses 1 plus 3x. And it's very important that I write those parentheses there, because by writing the parentheses there, then I know that I have to distribute that number to both pieces in that binomial. So when I do that, on this side, I'm going to get 8x plus 24. And on this side, I'm going to get 5 plus 15x. And now we're back to a algebra 2-step problem where we take the 8x, I'm going to move it over here this time. I'm going to subtract it there so that I get a positive 7x. Then I'm going to take this 5, I'm going to subtract it to the other side. 24 minus 5 is 19. And then my last step tells me to divide by 7 to both sides. So my final answer says 19/7. It's not a pretty answer. Not everything will be, but that's the answer. If you get 2.7 as a decimal, it's the exact same thing. Okay, but you don't have to convert it to decimal for me. Just leave it as a fraction if you want. If you're doing this on the yellow calculators, that double arrow on the bottom right-hand corner right above enter is how you convert decimal to fraction. Okay, let's move on to number 4. Number 4 says solve the equation and check your solution. If there's no solution, write no solution. So guys, when I'm being asked to add and subtract fractions, I need to have a common denominator. We talked about this in one of the sections, so we need to come up with an LCD, lowest common denominator. The very first thing I'm going to notice on here is I've got a single x and an x minus 12. Those ones I can't reduce anymore. Those have to probably be part of my lowest common denominator. But let's check that first chunk that says x squared minus 12x. What we've learned in class is first, let's get that in lowest terms. So I'm going to pull out an x because there's an x in both pieces of that denominator. By pulling out the x, x squared divided by x leaves me with an x. Negative 12x divided by x leaves me with negative 12. Now those two pieces should look pretty familiar to the other two pieces here. So really my LCD is just going to be a compilation of those two denominators, the x and the x minus 12. So remember when you're doing a problem like this, you have to ask yourself, what does my LCD have that my piece of my fraction needs? So if I'm looking at this 8 over x piece, the denominator has an x. So it's missing the parentheses. So I need to multiply this by x minus 12. And if I look at this x, or that 2 over x minus 12, I'm looking at this part and I'm asking myself, what more do I need that's part of my LCD? Hopefully you're thinking to yourself, you need the x, Miller. So I need to multiply that fraction times the x. Okay? So my first part of the fraction didn't need anything. That 5 is just going to have a 5. I don't need to do anything with that denominator. So I'm just going to bring the 5, we'll just write it over here. And I'm going to bring the plus sign over as well. But my next fraction, that 8 over x, has that green parentheses next to it. So I'm just going to literally bring that with me over here. Now some of you, I realize, are going to do the multiplication as you move it over. That's fine. I'm trying to show every step here. And then I bring the equal sign over, and then I'm going to bring that 2 times x over, which is just 2x. And guess what? We've got another algebra problem. Distribute and solve. So I'm going to do this one pretty quick, since we've kind of seen these already. Nope, 96, right? 96 equals 2x. I'm going to bring the 8 over here, and I really don't have a choice with that because of my numbers I'm combining on this side. So that's negative 6x. And then I'm going to divide by negative 6 to both sides. And I'm going to be left with, you could write it as x equals 91 over 6. Or if you really want to put that into a decimal, it's 15.1. Notice, though, that my negatives went away because I had a negative on top and bottom. Now, it says check your solution to see if there's an answer or not. The only time I'm not going to have an answer in there is if any of my denominators equals 0. Well, if I plug in 15.1 minus 12, that's not 0. If I plug 15.1 in for that x, it's not 0. If I plug it in for the x squared minus 12x, it's not 0. So I'm good. That's my answer. Okay? You guys learned it in Algebra 2 trig as extraneous solutions. An answer that doesn't work. Okay, number 5. So looking at number 5, it says solve by extracting the square root. Guys, when I say solve by extracting the square root, all I'm wanting you to do is solve this, and you're going to use a root. Okay, and what do we really have to remember whenever we use the square root? Every time you root, you got to remember the plus and the minus. Okay, and if you need to write yourself a note, then write yourself a note. Maybe you write yourself something like, when square root, use plus and minus. I mean, that's probably is about the minimum amount of words that you could use to write yourself a note on that problem. Okay? So on this problem, there's nothing in front of the parenthesis or behind the parenthesis, so I can just jump on square rooting right away. So if I had a number in front of here, in front of my parentheses, I would need to divide that to the other side. If I had a number after it that was being added or subtracted, I would need to do the opposite to the other side. So I'm going to square root both sides. And that leaves me with 3 minus 2x, because remember the root and the square cancel each other out. And then on the other side, I can't take the square root of 6. So my answer is square root of 6, but I got to remember that plus and minus. Okay? Now, just like we've done before, I'm going to subtract 3 over here. So that just gives me a negative 3 plus or minus root 6 on this side and a negative 2x on that other side. And then how do I get negative 2x to the other side? Divide it. So, can I reduce and get rid of those negatives on top and bottom right there? Yes, I can. Some of you are probably thinking, well, it doesn't have a negative in front of that square root sign. It does, right? That plus and minus is going to be a positive and a negative. If I take a negative out, isn't it still just going to be a positive and negative? I'm adding and subtracting? It is. So really my final answer should look like this. I can get rid of that negative on top and bottom. That was a pretty easy square root problem. So number 6 asks me to factor this problem. So since I don't have a leading coefficient here and it doesn't look like I have any GCFs, greatest common factor in all the pieces, I can just straight go to my 2 parentheses. Okay, if I had a GCF in there, I would pull something out that they would all have in common, like a 2 or a 3 or something. So now remember I asked myself for these first 2 spots, what multiplies to give me x squared? That's pretty easy, just x and x. This is actually a pretty easy problem. Now I need to look at this 15. And I ask myself what multiplies to get 15, but adds or subtracts to get 16. Well, 5 and 3 get me 15, but are they going to add or subtract to give me 16? No, because they're either going to give me a 2 or an 8. So really the only other option I got is the 15 and the 1. Okay? So I'm going to already throw 15 and 1 in here. And then I got to watch my signs. Remember, if this sign is positive, it tells me that both of my parentheses are going to be the same symbol. Okay? So, and this symbol right here always tells me what the bigger number is. So if I know they're both going to be the same symbol by the positive and my bigger number is negative, that makes them both negative. Right? So that's the question that you need to ask yourself. Now it says solve by factoring and my problem's equal to 0. So I'm really not done at this stage. What do I need to do with both of these binomials? Set them equal to 0. Okay? So all that means is I'm isolating x. So add 15 to the other side, 15. Add 1 to the other side, 1. Those are my 2 answers that would solve that problem that would make this answer 0. You can check this by plugging it into the formula and doing the math. 1 squared is 1. Minus 16 times 1 is 16. So 1 minus 16 is negative 15. Add 15 to it. Do I get 0? Check. You can do the same thing with 15. I'm just not doing it quickly in my head. Okay? The last one on this page is completing the square. This was new to some of you, so I'm going to go through this one step by step again on the recording. Remember, the very first thing you check is to make sure there is nothing in front of the x squared. Any number there needs to get divided throughout the entire problem and go away. Even if it leaves you with a stupid decimal or something. Divide it out all the way. Okay, this doesn't have that, so we can jump straight into doing the problem. Remember, your x's go on one side, and then I leave a space and I move these whole numbers to the other side. So this gives me a negative 2 with a space. The next stage, and I jump all the way to this part, and I've shown you guys this already. Remember, the number that goes in this binomial here is always half of b. So if you need to write b divided by 2 there so that you remember that's what goes in that spot. So 6 divided by 2 is 3, and I keep the same sign. The number that goes on those blanks is always this answer squared. So 3 squared is 9. And that gets added to both of those pieces. Remember, this green parenthesis that I just created that says x plus 3 squared is really just the factored form of x squared plus 6x plus 9 in that line above it. I'm just not spending the time writing that I factored it, okay? By doing that b divided by 2 and then squaring it, I'm actually doing that math without really having to do it, okay? Now we've created a extracting the square root type problem. To solve this quadratic, I need to get rid of that squared root, or that squared term on that green binomial. So in order to get rid of that, I square root. And I'm left with x plus 3 equals plus or minus root 7. Remember, I square rooted, so I got to make sure I remember the plus and minus. My last step with this problem is to subtract 3 to the other side. And I get the answer of negative 3 plus and minus root 7. And hopefully that made sense with how you complete the square. Okay, so we're going to move to the next page. So these two problems on 8 and 9, I ask you to solve using any method. So these are quadratics. It doesn't matter what we do here. I think for the purpose of the recording, I might actually do the quadratic formula on one of these because I want you to actually see it. So let's just do that on the first one just to see what happens here. I'll rewrite the quadratic formula. Remember, it's a is the number in front of the x squared, b is the number that's in front of the x, c is this number by itself. So the quadratic formula says negative b plus or minus square root of b squared minus 4ac all over 2a. And so at this point, all we're going to be doing is plugging in numbers and calculating. Okay? Not all of you will probably choose to do it this way. I'm just choosing it so that you guys can see all the methods in the recording. So this is 2. And remember, it's probably a good idea to put your numbers in parentheses, especially if you are going to plug this into your calculator, because Lord forbid it does the calculations wrong for you. Okay, so I'm going to keep going. This gives me a negative 2 plus or minus. That's 4. This is 12, 120, so 120, positive 120, because a double negative becomes positive, over 6. That's negative 2 plus or minus root 124 over 6. And the square root, when you plug this into your calculator, gives me negative 2 plus or minus 2 root 31 over 6. And because I have a 2 in this spot, and I can reduce this one by a 2 as well, so in all three of those places, I can reduce this more. Okay? It has to be in all three. So your final answer should say negative 1 plus or minus root 31. You don't need to put the 1 in front of there. Over 3. And it's not a great answer. It's not pretty by any means, but it is the answer. So the last one, I guess I can do quadratic formula 2 since it's sitting right here. That's 2x minus 9x plus 12 equals 0. I'm just going to plug it right into the formula. That's 9 because the b is negative, so I'm going to switch the sign. Plus or minus root negative 9 squared minus 4, 2, 12, 2 times 2. I'm going to draw a big old line here so we know we don't get those things messed up. Okay, since it's all the problems. This gives me 9 plus or minus 81 minus 96 over 4. Uh-oh. Do you guys see what I see? 9 plus or minus a negative 15 over 4. What happens with that negative in the denominator, or in the under the root? Hopefully you're thinking to yourself, I know this because it's going to be an I. Did you get the joke? Hopefully you got the joke on my recording. I think people in the classroom that are listening to this just rolled their eyes. Okay, so that got us through question 9. Let's look at question 10. It looks like a word problem. If there were 670 defects in Ford automobiles in 2001 and 149 in 2011, oh look, they went down, that's good. Predict how many defects there's going to be in 2013. Assume the number of defects continues the same linear pattern. It might not, but we're going to assume it. So really what they're telling us is, in the first year, in 2001, we have 670 defects. So what I think we should do is look at 2001 as like year 0. Like that's our initial year we're looking at, right? So that point would be 0, 670, as the year is the X, number of defects is the Y. And then we look at 2011. 2011 from 2001 is year 10 then, right? Because that's 10 years later. So if I look at that as a point, then I've got 10, 149. Well, if I've got 2 points, what can I do with 2 points? I can write an equation. They actually told me in the problem it's going to continue to be the same linear trend. So I know it's going to be a linear equation. So remember, in order to solve this, I'm going to take the change. First, I need slopes. Slope, remember, is this formula. So literally, I'm just going to plug in my pieces. Oh, I'm running out of room. Okay, so I'm going to plug in my pieces for my slope. And it says 670 minus 149 over 0 minus 10. I knew it was going to be negative, and the reason why I know it's negative is because my defect number is going down. So my slope, when I do this math, gives me 521 over negative 10, which is the same thing as saying negative 52.1. That is very important in this kind of a problem. If my number of defects are going down, that negative 52.1, and that's what I'm wanting you to do at this point, it wants me to interpret what the slope means. So what that means is every year we can expect the number of defects to decrease. How do I know it's decrease and not increase? Because it's negative by 52.1. Now, we know that it's not going to be 52.1. That's the average amount of decrease, right? But that's what we're finding over this 10-year span, that on average, it's decreasing 52.1 defects every year. If it was a positive slope, then we would say that it's increasing, and then that's not very good for their cars if they're increasing defects, right? Okay. Hopefully that makes sense. The second part says, when do you expect there to be no defects? Well, it also wanted me to know, predict how many defects there will be in 2013. So we need to write an equation, right? We can't do this without an equation. Y equals the slope, negative 52.1, times how many years we're talking about. We don't know how many years. Do we know what the intercept is? What was my initial value? Do we know when x is 0 what y was? Because that's the y-intercept. We learned about x and y-intercepts already. So when x was 0, y was 670 defects. So that's also known as my y-intercept. So now we have to find out what's happening here. So 2013, how many years after year 0, how many years is 2013 after 2011 or 2001? You should be saying 12 years, right? So 12 years would go in for my x. And that's how I'm going to find out how many defects are in 2013. Do we expect it to be higher or lower than the number of defects in 2011? Should be lower because I'm decreasing every year, right? Should be going down about 104. to be honest, because it's 2 times the slope. So I check that and I get y equals negative 52.1 times 12, we said, plus 670, and that gives me a magical number of 44.8 defects. That's getting pretty good, isn't it? Still not perfect. Perfect would be how many defects? 0. So that's what this second question down here says. When do you expect that there's going to be no defects at all? In order to find no defects at all, am I going to be setting my x to some number or my y to some number? Hopefully you're saying the y. The number of defects we want to be 0. Doesn't y represent the number of defects and the x represent the number of years? So if I want to know that the number of defects is 0, I got to set my y to be 0. Hopefully you're following that. So when I do this math, and I'm running out of room over here because I'm writing too big apparently, I'm going to just kind of squeeze this in here. 0 equals 52.1 times some number of years later plus the number of defects that we already know that we started with. And guess what I have to do? Solve for x. So I have to move 670 over, that's negative. And then I have to divide by 52.1. Negative 52.1. Thanks. And that gives me x equals, I got 12.85 when I plug it into the calculator. 12.85. Can I go 12.8? Like, is that a year? It's not that we're not going to 1285 as a year. 12.85 gets added to what number to find my year? To the 2001, right? 12.85 years after I originally started, so after 2001. So I'm going to just take 2001 plus 12.85, right? And so that should give you somewhere between 13 and 14, right? 2013 and 14? Because it's a decimal, correct? So when can we expect this? About 12.85 years later. So I'm running out of room. Approximately, that's the symbol for approximately. We'll say 2014. Because it looks like it's closer to 2014, right? 12.85 added to 2001's 2013.85. None of that was complicated math. That math was actually all stuff that you did back in algebra and pre-algebra. The hard part to the word problem part on the test is it's word problems. It's the context. You got to get it in context. But that's what I think is nice about math, is when you can put it in context, it actually makes more sense. Okay, so we are going to move on to the last 2 problems on this page. These are from Chapter 1, Section 5, I believe, when we did complex numbers. No, 6. We did complex numbers. Remember complex numbers with the I that we, that works kind of like an X unless we multiply. So with this, all this is asking me to do is combine like terms. But I have a subtraction sign in here. So every time I do it, I'm going to say 12 minus 3. Well, 12 minus 3 is 9. Then I'm going to say I minus negative 5i. What's that double negative say? I minus negative 5 becomes really I plus 5, which is really 6i. All I'm doing is combining like terms. Remember, the 9 is the real part, and this is the imaginary part. Okay? Now, 12, everybody looks at and is like, what the what? This is just subtracting fractions. When we subtract fractions, we have to have what? Common denominators. So, we have to ask ourselves, what does this have, but it needs in order to look like that? The easiest thing with something crazy like this is to just multiply this times the opposite denominator, and then this one times the opposite denominator. Don't overthink it. All I'm going to do is flip-flop those negatives, or those denominators. But please note that this is a subtraction sign in between it, not an equal to sign. Too many kids, when they decide to do this, they automatically think that that's supposed to be equal because it looks like a proportion. It's not. You actually have to do that math. So this first part, when I multiply these, I'm just going to rewrite it just so everybody can see it clearly. I don't know why I put the minus there. Erase that, sorry. 1 parenthesis 2 minus 3i minus, all I'm doing is staying on the top row, minus 4 times 1 plus 2i. And what should it all be over? My LCD. Okay. Because we're just getting common denominators. So that's no different than saying, like I got them up to 20 and I just leave the 20 down there. So now I need to do the numerator. I'm going to just keep that denominator in my final answer. The numerator, this gets distributed. Does that change anything? A 1 doesn't change anything. Does this negative 4 change anything? Yes. So really that second part I really got to focus on. So 2 minus 3i, and then I'm going to distribute the negative 4. That's my numerator, right? I got to combine it so it looks pretty. When I combine this, I'm left with negative 2 minus 11i, and we can just say it's all over this awesome denominator. I'm not even on this problem going to make you reduce that more. We could, but we're never going to get rid of that I in the denominator until we start doing the conjugate. We're not going to do that on this one. Okay, so that's the second page. Woo! Okay, let's move to the next page. Oh, this is silly. 13. Name 4 ways you can solve quadratic equations. Hopefully you guys know them. 1, probably the one that comes to mind the quickest, the quadratic formula. Right? That's pretty obvious one. Another one is square root. Well, actually, I gave you all the answers on this review. Think about it. Factoring is one. Square root method, or extracting the square root, if you want to be like precise. And then my final one is completing the square. I'm not even sure why I kept this question on the review. Those are all ways of doing it. Okay, so let's look at some inequalities, and it says we need to write this in interval notation as well. With regular inequalities, we just solve these like an algebra problem. So I need to distribute, and that gives me negative 6k minus 66, less than sign, distribute, negative 3k minus 6, and bring that negative 6k down as well. I'm going to move kind of quick through this one because these are pretty easy, I believe, for most of you. And then I'm going to get my k's all to one side. Well, I guess I should combine first. Negative k minus 6. Okay, and then I'm going to move this one over here so I can keep my k's positive. Plus, I like to have my variable on the left so that I can read it variable symbol number. And I'm going to move negative 66 to the other side so that becomes positive. And so that's 60. And then finally this says k is less than 20 because I divide by 3 to both sides. Now my number line looks like it goes by ones, but I'm going to magically make this go by 20s by adding zeros at the back of each one of those numbers. And then I don't have to redo anything. Now I'm going by tens. Magic. All I did was turn them all from 1, 2, 3, 4, 5 to 10, 20, 30, 40, 50. Makes it easier, right? Because we needed 20 as my number. See, sometimes I am smart. So we are going to look at this, and I'm going to put an open or a closed circle at 20. Open. Remember, oh, that's 10. Don't do it at 10. Do it at 20. Remember, these two symbols give me an open circle, and we also use a soft bracket for those, right? And then these two symbols give me a filled in circle, and we use a definitive bracket for that, a hard bracket, okay? So the arrow, since my variable is on the left-hand side, this symbol saying less than tells me which way to point, right? What numbers are less than 20? Well, we know that answer. All those numbers, right? Writing this in interval notation, remember we start from the left side, which would be negative infinity, and it goes to 20. Infinity always has what type of brackets? Soft, because they're unbounded. And this 20, since it's an open circle, is also soft. And that's interval notation again. Okay, absolute value with this. This will be probably our last one before we take a little break. Okay, now I need to, can I just break this into two problems right away? No, the very first thing I need to do is get that 4 away, correct? So this really says absolute value of 3 minus x is less than or equal to positive 4. Now I can break this to two problems. Remember when I taught the lesson, some of you choose to just do the exact, and then you choose to flip it and make it negative. Others of you choose just to slide the symbol over and write negative 4 on the other side. I personally do not have a preference on which way you do it, as long as you do it correctly. Okay? So I'm going to solve both of those problems. Since this one down here is already set up nicely, I'm going to just do it. Subtracting 3 gives me a 1. Subtracting 3 gives me a 7. Uh-oh, my x's are negative. Wah, wah, wah. What do I need to do with those? I need to flip that to a positive, which will make this a negative, but what does it also do to my signs when I divide by a negative? It flips them. So each one of these is flipping and changing what sign the number is. Anytime you divide by a negative, you flip the inequality sign. Okay, that was something I told you to bubble and highlight in your notes. So this one, I'm just going to put a filled in circle at -1 since it has that line under it. And I'm also going to put one at 7 over here, or just extending them a little bit longer. For 7, it says it goes less than that. For 1, it says it goes greater than that. So I know I'm staying between those two numbers. So my interval notation will say -1 to 7. And what bracket do I have on the -1? A hard bracket, because it's a filled in circle. What bracket do I have on the 7? Hard bracket again, it's a filled in circle. Now, on both of these examples, I had the same kind of brackets on them. Is that always the case on every problem you do? No, the brackets can flip-flop, one side be one side be soft, one side be hard. Just know that it's not always the same. Okay? Great. Okay, question 16 says sketch the graph 2x squared plus 2, then sketch another graph that has symmetry to the x-axis and label them both. Guys, the easiest way to do a graph if you don't know what it looks like is just plug in numbers and find out where they go. Okay, so you just plug these in for x. So a 0 in for x squared is 0, times 2 is still 0, add 2 is 2. Plug a 1 in, 1 squared is 1, times 2 is 2, plus 2 is 4. Plug a 2 in, 2 squared is 4, times 2 is 8, plus 2 is 10. So I still haven't got anything. They look like they're just increasing. I don't know where the other side is, it looks like. So I'm going to try a -1. -1 squared is 1, times 2 is 2, plus 2 is 4. Okay, it looks like I do go back up on the other side then. So I'm going to plot these 0, 2, 1, 4, 2, 10, -1, 4. That means there's another mirrored image right there because this is a quadratic. Okay? This is not a new concept. You guys know this stuff. Then, to have symmetry over the x-axis, remember this is my x-axis. So symmetry over that means that I've flipped this graph from upward to downward. Okay? So this dot right here is 2 units from the origin. That means my new dot has to be 2 units from the origin. Right? This dot here is in the 1 and it's 4 up. So that means I've got to have a mirrored dot, which is in the 1 on the 4 down. And I can keep this pattern going. Oops, I went over too far over here. And you can see I have symmetry over the x-axis. I marked it with y and y prime so that you can see which one of the graphs is which. I apologize for the student that just sneezed so loud. Okay, so I wrote on the next slide some bonus topics that you're going to be assessed on but weren't on this review. Things that you need to make sure that you know are intercepts of linear equations, writing equations from a verbal description, word problems to write the equation and solve from, which we kind of did on this anyway, equations of circles, and sketching a graph of x squared that graphs over a line or whatever, which I just did anyway. So really the first one, intercepts of linear equations, quickly just reminding you, the x-intercept and the y-intercept are found similarly. When I'm looking for the y-intercept, I make my x 0 in my equation and I solve, and whatever I solve for is my y-intercept. That's what number would go there. That's where it crosses the y-axis. If I'm looking for my x-intercept, I make my y 0 and I solve for my missing piece, and whatever that number is my x-intercept where it crosses the x-axis. Those are not new things. I didn't do those. A lot of you guys do them with like cover up maybe. That's one method that I know a lot of you have done with intercepts. The second one said writing equations from a verbal description. So those are ones that say like, if Sally is 12 years older than you and the sum of your two ages gives you 42, how old is Sally? So you would be X, Sally would be X plus 12 because she's 12 years older. The sum of you two would add up to, I forget what number I said. 42. We'll go with 42, because I think that was it. And then I solved the equation. We did 1-3 on this. There was a homework worksheet on this and a worksheet in class. But that's like a quick example of what I'm talking about. Word problems, writing equations and solving, that's like that one about the defects and the years. So make sure you know how to set up different word problems. If you need extra practice, I have some in the classroom. Equations of circles, that formula again, if you do not recall, is this, where remember H and K are the center points. Remember we always switch the sign when we put them in or take them out of the equation. And the R stands for the radius. So you square root that to know how big the circle is or not. Okay? That was, I'm trying to think what section that might have been. That might have been 1, 2, or maybe 1, 4. One of those two sections. And then we already just did, on that last example, to sketch a graph of x squared and do a reflection. So I don't think I need to go in depth on that one. So that will conclude the recording. I'm supposed to be corny and tell you guys to like and subscribe the YouTube, the video. You can join the Creator Studio if you really want to. It's super exciting. You too can have access to all these fun videos. Okay, have a good one and good luck on the test. It's your